on there. But let's go ahead and do it one more time. So first, to remove the natural log, so I'll have absolute value of y. You're going to have the exponential of this, right? So you're going to have e to the ln cosecant squared x, and then plus c. And as we already saw before, that plus c is going to have just an extra coefficient. It just becomes over here, and we'll call it c1. And then to remove the absolute value, you're just going to have a plus or minus. That plus or minus gets absorbed to your c1. And so you have y is equal to c2 e to the ln of cosecant squared x. And then e and ln are opposites of each other. They're inverses. So which means this simplifies further into y equals c2 cosecant squared x. And there is the simplified version of your answer, your explicit version of your function. Any questions on this? Any questions on it? So again, if there's only a single y on your final sort of answer, right, you need to solve for that y. Okay. Pretty much almost always. Okay. If there's only one y. Okay. Oops. Moved. All right. Our last example, at least for now, we're gonna finish more of 2.2 next time. But I want to show you an example of an initial value problem. Okay, so I have it as x squared minus 1 y prime, okay, plus a 2x y squared equals 0. And so what makes a differential equation initial value? It's going to have initial conditions on it. So in this case, y of radical 2 equals 1. So meaning, since initial conditions are given, at the very end, you have to find the value of your constant. Okay. Questions on that? Okay. All right, so I don't know if we're gonna have time to actually give you the time to work this out. So let's go ahead and work it out together. So first, I need to solve for y prime. So x squared minus 1 y prime is equal to a negative 2x y squared. Then divide this to both sides, and I'm going to write this as dy dx. Okay, divide the y squared, right? That's the step you need to do. So 1 over y squared dy is equal to a negative 2x over x squared minus 1 dx. The right side is a u substitution, right? So let u be x squared minus 1. Du is a 2x dx. So there's going to be a negative left over. Okay. Then the left side is your power rule. So so this would be a negative y to the minus 1 is equal to a negative natural log of x squared minus 1 plus c. Okay. The negatives on both sides should be able to cancel. So multiply everything by negative 1. So you get y to the minus 1. So this becomes a positive. And this becomes just a new constant because you multiplied by negative 1. So that's now a new constant. Now on here, it is up to you when you want to find the constant. So you can find that now and then solve for y, or solve for y and then find your constant. So right now, I think it's easier if I solve for the constant now and then figure out what y is once I have the constant on there. So I'm going to go ahead and apply my initial condition. Okay. So x is radical 2, y is 1. So this becomes 1 to the negative 1 power is equal to ln of radical 2 squared minus 1 plus c1. And so this becomes 2. 2 minus 1 is 1. Ln of 1 is 0. So this is 0 plus c1 equals 1. So which means c1 equals 1. So this function, okay, is 1 over y equals ln of x squared minus 1 plus 1. And then now solve for y. Well, the easiest way to do it is to flip it, right? So it's 1 over y and then do the reciprocal. And so that means y is 1 over ln of x squared minus 1 plus 1. And there is your final answer. And now you can see why I wanted to solve right here and not over here, because I knew I had to flip and get fractions, and I don't really like working with the fractions on there. And so I left it here so that I don't have to worry about the fractions until I actually have my answers. Okay. I don't think it would have been a big deal because I think the answer would have been 1 anyway, and so you'd be able to do the reciprocal pretty easily. Okay. So any questions on these? Okay. All right, now we're not completely done with 2.2. So there's a couple more things I do want to go over. So those two things are basically what happens is your differential equation is not separable. So you can't separate your x and your y the same way we've been doing the 6 problems that we saw now. However, okay, by doing a substitution, you'd be able to simplify the problem to something else that will be separable. And so we're going to do that next on Thursday. Okay. But any questions so far on this? All right, so I will open 2.2 homework. Obviously, it's not going to be due until later because we didn't finish it. But 1.1 and 1.2 are finished. So I am going to open those homework, and you should be able to do both of them. And so and finish them as well. But 2.2, there's a few problems on there that obviously require substitution. So since we haven't done that, we're going to have to wait on the due date on it. So I'll open those homeworks today. I'll upload the videos eventually on YouTube. It's going to take me a while to break them apart. Okay, um, and so we'll do that probably later today. And then the last thing I do want to say, since next week is spring break, all your homeworks are going to open during spring break. So if there are any homework problems or online homework you did not finish, you should be able to go back and do them during spring break. And so you can make up whatever homework you missed. Okay. Any questions on that? And then one last thing, if you sort of talk to uh, a schoolmate, a fellow student that's taking the same class as we are, we were basically asked, or at least not asked, but said that it was optional that we can drop some of the sections we have to cover, right? So they told us, oh, these sections are now going to be optional. It's up to you if you are going to um, cover them. Looking at our schedule, I don't think um, we're going to need to omit any sections. Okay, so just keep that in mind. We're probably not going to omit anything as far as the sections are concerned. So I think we're still going to be able to finish everything that's on your syllabus.